team, and in this short video demonstration I'm going to be showing how we can access a locked BitLocker drive using the data found from a memory.dump file created from a blue screen of death file. So here you can see an encrypted E drive in a virtual machine I've created, and that VDI file simulates a 10 gigabyte hard drive attached to a computer. Here our user is unlocking the drive, and once they've unlocked the drive, the data within the drive is accessible. So you see I just put a small single text file in there saying you are in, well done, to show what the user's data would have looked like once you've accessed that device. So now we're going to use a sysinternals tool to simulate a blue screen of death crash. That tool there you just saw me quickly using is called notmyfault.exe. And what a lot of people don't realize is when you crash a Windows machine, you can see this 20-30% coming up here. This is dumping the RAM, or at least the RAM that was in use and parts of the page file to a file that you can use for forensic analysis. Here in a bit of a Mary Poppins, here's one I made earlier scenario. I've already acquired a copy of that memory.dump file from another crash whilst the BitLocker was opened. And when I'm going to run Python and type the command bitlocker_carve.py and feed it in that memory.dump file, and that's going to carve that file looking for volume master keys. You see there, it only took a few seconds, and we've got this long string of characters here, which we're going to be echoing into a VMK file to be used within Kali Linux to get access to that hard drive. And apologies if this video demonstration is quite quick, but I was trying to keep it succinct for people. So here we have another Kali Linux machine where I've attached that 10 gigabyte hard drive. And if we go sudo lsblk and type in the sudo password, we can see two hard drives attached to this virtual computer. SDA1 is the partition of the first disk that we're using for Kali Linux, and SDB1 there is our suspect machine where we've got an encrypted hard drive we can't get into because the suspect has either forgotten the key or won't let us into it. So if we paste our first command in here, we're going to need two folders in the mount point, mount BitLocker to mount the BitLocker information itself, and then once the BitLocker has been mounted, BitLocker_unlocked for the NTFS partition within the unlocked data. So actually, we're going to be doing the unlocked data in BitLocker, but unlocked is quite easy to understand. I'm just going to pause the video here because it's running ahead of me a little bit, but you can see here in this command, we have an echo where we're echoing the command that we recovered. So if we just pull in the command input from the other side, there we go, and pause it again. We are going to take the hex and we're going to push that hex as hex into a second file called VMK. Please ignore the two, that was just from testing. It's just my machine predicting it there. So once that wiggly VMK file comes in, we can now start unlocking this with a lovely tool called BSOD, which can be downloaded freely to your Ubuntu or Linux machine, whatever you want to do. So in the first example here, I'm going to do a quick man command for BitLocker and show you the different options. There are two very similar commands in here, one with a small k and one with a large k. What we've recovered is the volume master key, so you make sure when you're doing this, you need to do a very large k, not a lowercase k for the VMK file. And again, when you see me typing the commands in here, this is quite a good mistake to see because when you go on the internet, you look up advice on how to do this, it'll tell you that you can do the large K and actually type the VMK value straight into the command line. Unfortunately, that really doesn't work, aside from people saying that it's something you can do. So if you get rid of the VMK, even though the manual says that you can do it, and lots of people online say you can do it this way, you then have to specify the path of the VMK file you've just created, and hitting enter. If you get no output here, you've now successfully mounted that person's BitLocker from SDB1 very easily, but we need to prove that and have a look at it. So what we're going to do a loop command, and we're going to loop the BitLocker mount with the new dislocker- file with inside it, and we're going to mount that in a second hard drive called BitLocker_unlocked, and that will mount the NTFS partition data so we can preview it in the machine. But if you were using a forensic workstation, you needed to acquire this data, you could just acquire that BitLocker- file data, and you'd be absolutely fine. You could decode that in your forensic software. And we're just going through with the BitLocker unlocked, mounting there, and you can see with a small ls command, URL well done is displayed. There's a lot more information about how useful these files are for forensic investigation, some of the really good food for thought and examples on how you could do it. And I hope as well this will act as a good message for people to show that as happened in the Storm 0558 situation, when you give that a Google and look up the event information, APTs were able to get API keys from uploaded BitLocker no, I'm sorry, uploaded blue screen of death files where sensitive information was revealed in there. So just kind of think about your blue screen of death files when you see them in your investigations, whether they might hold information that would be useful, even if it's been wiped from the machine at a later point, and also potentially get you into these encrypted volumes. If you'd like to have any more information about this, please contact me directly. So it's stephen.fisher-davis@airbus.com. Information and further contact details on our intranet page. Thank you for watching.